Hello, and welcome back to another video. We're going to be looking at the muscular system today. So first little challenge, let's get our minds a little bit ready. How many muscles do you know? How many can you name? So I'm going to try and remember some and see if you're going to get them as well. So deltoid, biceps, triceps, trapezius, latissimus dorsi, glutes, hamstring, Gastroenemia, quadriceps, abdominals, pectorals, tibialis anterior. Oh, I'm running out. Maybe you've got some of those, maybe you've got more. You can just write them down. So we'll look at a front and rear view of the human body, so you can see all the muscles on there. So the deltoid, and that helps with the abduction of the arm at the shoulder. For example, if we were bowling a cricket ball in cricket, the shoulder, the arm comes up and over, comes away from the body. Remember, abduction is to take away from the midline of the body. Then we've got triceps and biceps. So the triceps allow for the extension of the arm at the elbow joint. For example, when you throw a javelin, you've got your arm out straight when you're running with the javelin to start with, and then you throw it and your arm goes straight when you let go. You've got the biceps, which allow flexion of the arm at the elbow joint. So if you were doing a bicep curl, when you bring the weight up towards your shoulders, you're doing the actual curl movement. That's what the biceps will be used for. Latissimus dorsi, these are responsible for the movement of the shoulder and lateral flexion of the spine. So flexion of the spine. For example, if you're rowing in a boat and you pull the oars, and there's flexion in your spine. Okay. Then what else we got? Gluteal muscles. These help obviously with the movement of your legs around the hips. So if you think about a sprinter, when they're sprinting out the blocks, and then when they're sprinting through the race, it's pushing off your feet. The gluteal muscles help with that. What else? We've got gastrocnemius, that allows flexion of the foot at the ankle joint and the leg at the knee joint. For example, when you're taking off in the high jump to jump over the bar, the gastrocnemius help with that. They help give you some force to jump. The quadriceps, these allow extension of the leg at the knee joint, and the hamstrings as well. They allow for flexion of the leg at the knee joint. So a good example is when you're kicking a football, the flexion allows for your knee to bend before you kick it, and then the quadriceps allow for extension of the leg as you kick it. So when you've had your shot, your leg will be nice and straight. Abdominal muscles, they allow for flexion of the trunk and assist with your breathing. For example, a pike in gymnastics or trampolining, when you jump and you touch your toes to your fingers, your legs come up and your hands go to your toes, and that's a nice bit of flexion in your abdominal muscles. And I think the last one to look at is the pectorals, and these are responsible for movement around the shoulder joint. For example, in netball, when you do a chest pass, and there's movement at your shoulders as you push the ball away. So yeah, hopefully that's jogged your memory. I know I say that in literally every one of these videos. Hopefully that's been a bit of help. There might be some we haven't quite looked at, like the obliques and hip flexors, but you can have a look online or in your books or whatever. So we'll just quickly recover this. We've done it in lots of the other videos, but understanding how the muscles are actually engaged and work. So we know that muscles are attached to the bones by tendons. So the tendon at the non-moving or fixed end is known as the origin. This is just a bit of extra information. And the tendon at the moving end is known as the insertion. So where it moves, that's where it's been inserted, that's the insertion. So muscles can only pull. They can't push to create opposite movement. So muscles pull by contracting. Oh, sorry, my alarm's just gone off. Bear with me. So muscles pull by contracting, they can't push to produce opposite movement. And because of that, we have to have muscles arranged in antagonistic pairs. So there's two muscles obviously in a pair, and both of them pull. So when one's not pulling, the other one's relaxed. And then when the other one relaxed, the other one pulls because they can't push. So that's why they're in pairs. As we said, as one muscle contracts, shortens, its partner relaxes, lengthens. They swap actions to reverse the movement. So there's two different types of pull. The agonist muscle is the prime mover, the one that contracts, and the antagonist muscle does the opposite and relaxes to allow movement. Now if we think of flexion and extension, when we think of flexion, it gets smaller and contracts, so that's the agonist, and the antagonist lengthens, it extends and relaxes, and that's how I remember the difference, because the word antagonist is longer than the agonist, so that's how I remember it is the one that's relaxing, because it's lengthened. Okay, the muscle's been lengthened. Hopefully that makes a bit of sense. If you've got a different way of remembering it, of course use that one. So if we look at the arm, for example, the biceps and triceps are an antagonistic pair. They work to create movement at the elbow joint. So to flex the elbow, which means if you're bending the elbow to bring your wrist towards your shoulder, the biceps, which is the flexure, creates flexion, it contracts, and the triceps underneath the top of your arm relaxes and extends, the extensor. And then if we wanted to extend the elbow, say we've got our wrist at our shoulder and we want to bring our wrist back down, then we extend the elbow and the actions become reversed. So the tricep contracts and the biceps relax, okay? And that's the opposite pull. So to flex the elbow, the bicep contracts and pulls, and the triceps relax, and then to extend the elbow back down, it's reversed, and the triceps then contract and pull, and the biceps relax. That's why they're called antagonistic pairs, because you need one to pull one way and one to pull the other way. And then another example is in the quadriceps and hamstring. So when these are creating a movement or a muscle action, they're another antagonistic pair. So can you answer the following questions? Which joint do they move? So look at where they are and look at the joints they're near. Hopefully you can see that they're near the knee joint, so they help the knee move. Remember the example we talked about at the very start of this video about kicking a football? When you kick a football, you're moving your knee, aren't you? You're bringing it back to get your power, and then you kick and follow through and your leg straightens. So when you're bringing it back, your hamstrings are the flexor, they're contracting, and then when you're bringing your knee forward to kick the ball and straightening your leg, your hamstrings relax and the quadriceps contract, they're the agonist, and the hamstrings are the antagonistic part of the pair. So let's see, what types of movement are produced? We just talked about that, flexion, extension. At the knee, remember it's at the knee joint, which is a flexor, which is the extensor, so we just talked about that. The hamstring, when we bend our knee back, the hamstring is the flexor and the quadriceps is the extensor. And then origin and insertion of each muscle. So if we go back quickly, the tendon at the non-moving fixed end is known as the origin, tendon at the moving end is known as the insertion. So the insertion would be the knee, and the origin will be at the top in your, oh god, that's a good question. So origin and insertion of each muscle. So the hamstrings are the origin, and that's at the pelvis, and the quadriceps attached to the knee and the patella. But you should be fine with that. Hopefully that's helped. And then we'll just look at some antagonistic pairs in action. So the gastroenemia, which is your calf at the back of your leg, and the tibialis anterior. What joint does the do they control? And that would be the ankle. Which joint does the quadriceps and hamstrings control? We just discussed that. That's the knee. Which joint does the biceps and tricep control? We discussed that earlier about bringing our wrist up and down to flex and extend our biceps and triceps. That's at that elbow joint. And then which joint does the hip flexors and gluteus maximus control? And that's the hip. So if you try and remember those four, you should do fine. And that's antagonistic and muscle pairs in action. That was today's video. Well done.